Good evening, everybody. It is office hours time again. In fact, that sentence even has a little bit of a connotation to it, which I'll get to in a second. Sing out on the chat line if you can't hear me or see me. Hopefully it's all working. It's been a while since I've done an office hours session, so I want to make sure I don't stuff up anything, make sure everything's recording and that we don't lose anything. But hopefully the chat's working and all that kind of stuff. But I'm sure you'll let me know if it's not. Now, I've never done a Zoom poll before, but I want to launch this one and see what happens. So if I launch that, can everyone see that? The reason I said office hours has an interesting consternation is there's some debate going around inside Oracle about a rename. The term office hours is very USA specific, and so there's some things being bandied around. So yeah, there's some ideas there, like if you want to have some thoughts as to what do you think. I'm ambivalent. I have no particular preference here, but I know these are the some that have been sort of talked around in as well. So I'll leave that up and running for a while as people join. You're all welcome to have your thoughts, or you put your things in the chat, and we'll take it all on board. I would love to say I have some decision-making power in this process, but no, it'll all get fed up the chain, and someone higher up in the Oracle hierarchy will make that call, and then we might keep it the same or we might not. We'll see how we go. So anyway, we'll leave that going. Let me share my screen. On this on the chat line. So yep, hello from Miami. Oh hey Philip from Miami. Great to have you here. For those who don't know, check out Philip's blog. He's been doing some amazing stuff on it recently regarding AI and United Codes. Okay, let me share my screen. First of all, as if you're new to office hours, you might be because you haven't seen me for a long time. If you see some of the content shifted across somewhere, don't panic. This is such that when we turn it into a YouTube video, hopefully none of the content is blocked out. I always start with some bits and pieces about what's happening in the world in terms of Oracle and what's happening in particular in terms of user groups, because I'm a huge fan of them. First of all, unless you've been living under a rock, you would have seen that SQL Developer for VS Code 25.2.2 has come out. Now, that's not just a set of bug fixes and slight new features. The big thing really is this thing, an MCP server for Oracle database. MCP is all the rage. Everyone's talking about it. There's MCP servers and tools floating around everywhere. If you're unfamiliar with any of these things, effectively, it's a nice little liaison between a large language model and the ability for them to actually do something or request something to do, a process to do something on its behalf. So for example, here with the MCP server inside VS Code, I can say, please connect to the database and list some tables for me. And our SQL MCP server says, oh yes, I can help out that request. So the LLM talks to it. It talks to the database on its behalf, and it can come back and present that data back to the LLM, and the LLM says, oh, the chat thinks, yep, yeah, it's fine, there's some data for you. So it's effectively a really cool way of effectively accessing your data and your database and providing information out to a nice chat style interface. There's obviously a lot of webinars floating around about what we've done there, but if you want to hear more, obviously you can ping me after the session, but there's obviously plenty of content out there, and obviously we're pretty excited about it. In terms of using it on a database, 23AI, we've freshened up the free version. So if you're on Autonomous now or you're on your own free version, you'll see now it's 23.9. That came out, I think, in July in terms of regular RU cycle. I've got to keep an eye on the chat, don't I? Okay, Judith is not happy with the MCP presentation. Oh, we'll get some more if we keep you happy, Judith. Okay, I'm going to end the poll. Okay, hopefully everyone's seen the poll so far, and that's interesting. Yep. Okay, we'll end that. Okay, in terms of what I've been doing, the reason we didn't have office hours in June is I was at Ascend in Florida, a really interesting event, even though it's predominantly about apps. It was interesting to be along there and do some database talk there. Then in July, I went to Kscope. Heaps of people at Kscope, really fantastic event, strong developer focus. So yeah, just catching up with lots of friends. That's a picture of the ACEs that were there. Shout out to the ACE program that were there at the event. And then at the end of July, I went to India for the Yatra tour. I worked out 34 presentations across the week, so a busy time. But once again, the future of IT is looking great. Some of the sessions were held at university campuses, lots of young people there, just, super energized, etc. Once again, some of the aces involved, and lots of selfies. There's me in a traditional Indian headdress. Those two people there run. They're actually, one of them is the head of IT, I think, and the other one, I think, is the dean of the campus at a university in Pune. So we had literally 300 or 400 just students coming along to learn about Oracle tech. They actually run Oracle as part of their syllabus for IT there as well. So just tremendous fun. Okay, what's coming up? Cloud World. Cloud World is just around the corner at in October. So hopefully, I know for anyone that's watching this in Europe or not in the States, it's a big hike. But if you can get to Cloud World, it's certainly a good once-in-a-lifetime experience if you've never been, especially if you've never been to Vegas. If you're planning your agenda, I'm an Apex nerd, as you can imagine, and so I put together a little Apex app. So if you want, you can browse the schedule and build what you want to do. Just go to bit.ly/AIWorld25. Yes, and of course I said, it's this funny how I got Save the Date Cloud World here. This is my slides from a couple of months ago. I'm sure people are chat's lit up already. It's AI World now. Once again, a name change that I don't get to make. But so AI World. You can browse the agenda using the familiar faceted search in Apex as well. So lots of cool stuff coming up there. If you do come to Cloud World, please, if you do come to AI World, please come out and I'll be at the database booth a lot of the time. Come say hi. One thing I will say is if you are coming, it was really sad last year. I ran a session which was a lot of fun. It was just all demos on 23AI. But we had to turn a lot of people away at the door, not because the place was full, is because in the way it works is you have to click the heart in your schedule builder in order to be let into the venue. So please, if you are coming to Cloud World, make sure you tick the red heart there such that we can actually let you in the door, because that was a bit frustrating people for last year. Sarah said, won't AI World pick the agenda for me? Funny you should say that. In my Apex app, I actually have a AI chatbot as well, where I can just literally say, build me an agenda. And if you go to my blog, you can see an example of that. The reason I didn't make it public is this is a personal app of mine. And so, of course, the Open API AI key, the OpenAI API key is mine. It's my credit card. So as much as I would love to share that chatbot facility with you, that would be plundering away at my own personal credit card. I'm a big fan of the community, but not that much. So Sarah, it will actually, there's a chatbot in there as well. And if you search, it's very easy to build chatbots inside Apex as well. So what's coming up? For me, in 10 days' time, I'll be at the Poland Oracle user group, a really deep dive tech level user group, very much focused on really deep into the tech. So that slide there is now out of date. I think they're down to the last 10 tickets, but it's a really fun event. So if you're anywhere in Poland, in Europe, skip over there. And as part of that same trip, I'll be jumping in for a day in Vienna at the Oracle office in Vienna. So if you're in Vienna, please come along and say hello. You can get to that at the AOG website. That's on the 9th of September. And then on the 11th of September, I'll be in Bucharest, first time Romania. So anyone that's in Romania, I'd love to see you once again at the Oracle office. It'd be great to catch up and actually meet face to face, not just over the thing that is office hours. And as I always say, and hopefully I prove my example here, support your Oracle user groups. Those face-to-face things are so important in my view. Okay, someone's got do I know when Apex 25.1 will be released? I would love to say, yes, I do, but I'm not going to share it. That would be good for my ego. But no, I don't have a date for you. Those things are kept very tightly controlled. I could say soon, that would be my guess, but that's me speaking for myself, not speaking as an official Oracle position. I know at Kscope, we did a number of Apex 25.1 demos and etc. So I'm sure the product is very, very close to ready, but I don't have a date for you. So what do we got on tonight? Okay, we've got DataPump and mixed case names. These are the questions that have come in from you, the community. Large strings seem much slower. Change in the data type on reference partition tables, an issue with compressing lob segments, optimizing queries that have virtual private database or row-level security applied to them, software as a service schemas and contention issues, the concept of when people use one database to serve many, many customers, so they have the same application running against many schemas, and slow import of optimizer stats. So a little bit of development stuff, a little bit of DBA stuff as well today, and hopefully there's something in there for everybody. Okay, DataPump object names. Here's the question that came in. Our third-party application has all of its table names in mixed case. I love when people say our third-party application. No one's ever going to admit that they did this themselves, like, oh, it was a third party. We're trying to use DataPump to populate our test environment with some tables, and we can't get it to recognize the table names. Does DataPump handle mixed case? And the answer is yes, it does, but the interaction with DataPump and the operating system can sometimes cause some consternation. And so I thought I'd do a little demo of that and how it's very, very easy to work around. This will be a nice quick one, but effectively easy to work around, but you just need to take a little bit of care. So let's get things up and running. So I'm going to create a user called demo, just an empty schema in this database with 200 megabytes on users. I'll give it a little enough to create some stuff. And I'm granting read write on a directory called temp because I want to be able to do a data pump as this user. So here's an example of a lowercase table. As you're familiar, if you're not familiar with Oracle, by default, everything is stored in uppercase, which means you can refer to it in any case, and we transpose it to uppercase by default. If you want to actually have mixed case stored in the dictionary, then you must surround those names with double quotes. For example, here, lowercase, in order to actually preserve the case. So let's now try DataPump that out. And I've just put here, for example, DataPump, there we go, in lowercase in quotes, and it says I can't find it, which is a bit perturbing. And this is the problem that they're having. And if you do a bit of Googling around, you'll see, yes, the way to run it is sometimes they say you have to escape the characters. So let's try that now. I'll try escape those characters. And DataPump gets in an awful state here. And interestingly, this takes forever to come back. Like this, DataPump has just literally got itself in such a quandary that it doesn't really know what to do. So that's why I've got two scripts here. I actually had to kill this one off. So I'll close that one off. And you can see this obviously doesn't work. So in a brand new session, let's see what we actually have to do. We actually have to have a quote followed by an escape, then escape the double quote, and then it all works. And this actually isn't an issue with DataPump. This is an issue with how you specify these things on the operating system. On Unix, it's slightly different. You actually don't need the single quotes. You can just get away with the double quotes and the backslash. But in Windows, you have this sort of odd scenario because a double quote is special in Windows. Whatever the case is, right, this I think is just a pain in the butt. So the first thing I'll do is not be doing it effectively with, lowercase tables in the dictionary if possible, mixed case. But if it's a third-party application, then obviously you're stuck with it. What I prefer to do is anything that I'm doing in DataPump, I just put it in a parameter file, because then all those operating system idiosyncrasies are removed from you. Once it's in a parameter file, there's no backslashes here, there's no escape characters. I literally have the single quotes and then the double quotes to make sure it's in lowercase. If I do that, then I'll delete my previous file and it just runs fine. That would be my recommendation to you, right? Just use a parameter file always, because that parameter file will now work whether it's Windows or Unix or any other operating system platform. It's consistent across platforms, and you don't have to worry about what particular escape characters have to get used, etc. For example, I think in Windows also, I think a backtick will actually work. You could actually skip, I think, the single quotes and use a backtick on the double quotes. But yeah, there's all these variations on a theme, but why bother? Just put your stuff in a parameter file and have your program run that. That also gives you some maybe slight better security in the sense that the username is not going to be exposed from a process listing, etc. But either way, parameter files just make life easy. That's why the feature is there. Don't worry about all these escaping of quotes and stuff on the command line. But that's how you export mixed case things from the dictionary. And that's number one done. Making good time. Okay, number two, slow large strings. Here's the question that came in. We have set max string to extended, and we found that dealing with strings seems to be slower and or more CPU intensive, but only on the tables we've created since we did that. Can you help explain? Now, I didn't do any demo here about how to set max file string size to extended, so I'll do a tiny quick overview. Up until Oracle 12, I think, or maybe 19, maybe 12.2, The limit on a varchar 2 was 4,000 characters. People said we'd like more, please, and so we introduced this parameter called max string size, and you could have it standard, which is the default, or extended, which bumped up the varchar 2 limit to 32,000. Many people are familiar with this. It's not just a case of change that parameter. There's actually some database dictionary scripts you have to run to enable this, but once it's done, then you bounce your database, then you can now have varchar 2 32,000, which is super cool. The key thing here is the implementation details, which explains this difference that this person is seeing between certain tables. And to have a look at the implementation details, we have to dive into the database a bit, and so we'll do a demo for that. Now, on this database, I've already gone through the process of converting it from a standard to an extended. So I'm allowed to do varchar 2 32,000 in this database. I'll spare the gory details. I'm going to create a table space here, a brand new table space, just so I have access to the file level details in it, because we're going to go digging into the block internals in the database, and putting it all in a separate table space just makes life easy for me. So I'm going to create a simple table here called T1, and it's not using the extended file syntax. It's just using 4,000, just your stock standard file. Table 2 is varchar 2 32,000, so it is using the extended syntax. It's taking advantage of this new larger limit. I'm going to insert the same data into both. Into T1, I'm inserting 4,000 characters, and into T2, I'm also inserting 4,000 characters. So even though the scale of T2 is larger, in theory, the data inside these two tables should be the same. Now, in order to dig around inside to see how this data is actually stored, we have to get a little bit deep diving here. So what I'm going to do is I'm going to find out the file ID and the block ID for that row we just inserted into table T1. So the file ID I can get from DBA data files. The block ID I can use DBMS row ID to actually find for the given row, there's only one row in the table, what the actual block is stored. Now that I've done that, I can actually dump out the block for that particular file and block. That is dumped out to a trace file. How do I find where that trace file is? I have to go look in $diag info. That tells me what the trace file is. Now I can actually query the trace file itself. Even though it's an operating system file, that trace file is exposed in a view called $diag trace file contents. So I can actually expose that. I'm actually just picking up, effectively, I'm looking for the part of the block dump between the words ITL and col, and I'm going to spit out just that much. And so we end up with this. The block dump itself is actually huge. It's like, a very large trace file because it dumps all the contents of the block, both in hex and this symbolic version. We're just interested in this little tiny bit here. In fact, we're only interested in this last bit here. My table T1, which is a varchar 2 4000, when I stick 4,000 characters in there, it says, yes, column number 1, the first column in there, consists of 4,000 bytes. And those bytes are all 78, which I think is the ASCII code for, what do I put in there? X or something. So it makes sense. Varchar 2 4000, put in 4,000 characters, and I get 4,000 bytes in the file. Let's do the same thing for table 2, which has the same data, 4,000 characters in there, but it's a varchar 2 32,000. I dump out effectively the same block. When I do the same thing, find the trace file, dump it out, I don't get 4,000 bytes. In fact, it says column 0 is 38 bytes. Now, what is going on there? Those 38 bytes are a clue as to what's going on inside this table. If I go look at user lobs for table T2, now remember, table T2 has no clob column defined in it. The database just gave us one. When you create a table which is varchar 2 over the limit of 4,000, in this case 32,000, the way we implement it is we said, well, it's a very large varchar 2. We'll store it as a clob. It's like a silently implemented clob for you. We actually went and created a clob. In fact, it's syslob this. It's the first column. You can see column number 1 in this particular object. It's actually a lob segment. A lob locator, which points to where data is typically 38 bytes long. That's why you saw that column of 38 bytes, not 4,000 bytes in the block dump. We've actually implemented the large varchar 2 as a clob, and we're using all the normal clob semantics. So what happens if I take table T1, which was varchar 2 4000, and we saw when it stores data, it stores it as 4,000 bytes, and say, well, I'd like this column to now be 32,000 bytes in size. Well, let's have a look. I'll stick another value of 2 in there, dump out the block again and have a look. There's my trace file. And what do I get? I get 4,000 bytes still. If a table starts as a varchar2, in this case varchar2 4000, and we push it over the edge to become into the realm of what we would say is going to be a clob, we can't just effectively effectively change the data. That would involve unloading and reloading the table. So it stays as a varchar2. It's now just a varchar2 32,000. Now that raises a problem here because a typical block is 8K in size, and if I want 32,000 bytes, that's obviously not going to be stored in a single block. So if we go look at there's no lob there for table T1. There is no lob. So let's now explore this with a brand new table with a brand new piece of data. Varchar2 4000. Now we've got table T3. I'll modify it to 32,000. Insert 12,000 bytes in there. So in this case, once again, because we started with varchar2 4000, it's stored as a varchar, not as a clob. I modify it to 32,000. That stays as a varchar. I've now got 12,000 bytes in there. There's no lob, as we saw. How am I going to store that data? Well, let's dump out the block again. Look at our trace file. The first block is 4,035 bytes, basically everything we could store in that block. I'll go get the next block, stick it out. There's another 7,900 bytes. So we're actually chaining the data together in order to get to our 12,000 bytes. This is the fundamental issue that's coming up here. There's a fundamental difference between if you create a table with varchar2 very, very large, or take an existing table and modify it to varchar2 very, very large. Now, the question is, which is better? Well, that's sort of a six of one and half a dozen of the other kind of discussion. If a lot of my data was small and my table started as a small varchar2 and got large, then leaving it as a varchar2 format is probably a really good thing, because most of the time the data is going to be stored just in one block in a standard varchar2 format. There's no overhead of using a lob locator to go hunt down through a lob segment. However, if your table started small and then you made it large and all the data in there is very, very large, then you're getting none of the benefits of lob storage that we normally have for large amounts of data. What you're now doing is taking typically, say, 32K of data and chunking it up into 4K chunks or 6 or 7K chunks and splitting it and chaining it across multiple blocks. All the downsides of row chaining then come into play. In that case, lobs would have been better. So you just need to be aware that just because you make something varchar2 32K doesn't mean in all cases it's just a simple varchar, and it doesn't mean in all cases that it's a lob. It depends on how you created the data and how you evolved it to become a 32K table, and then you can make an informed decision hopefully now to deciding, well, maybe I should actually unload and reload that table with the large data type to make sure everything becomes a lob because all my data is large. Or maybe I could even take a table that was created as a varchar2 32K, but only has occasional data that's large. You could actually unload that table, create it as a small varchar2, and then extend it, and then reload the data in. So the storage semantics are then varchar2 for the vast majority of data. But at least you have the choice. We don't publish this anywhere. We don't actually say how the storage is done, but that's, as we can see, that's how it's done. So at least now you can make a qualified decision as to what's going to be best for your particular use case. So hopefully that helps. A reference partitioning. Here's the question that came in. We need to increase the size of a column that is being used as a reference partition key. All of our attempts end with error, and support said we should reload the table. Our table is 20 terabytes. Is there another way? You will need an outage, but luckily you won't need an outage that involves unloading and reloading 20 terabytes. It'll only need to be a tiny outage. Now, it requires a few little hops and steps to get this done, and so we'll do a demo here which shows you where the problem is and then how we work around it without having to shift that large volume of data around. So I'm going to create a reference partition table. If you've never seen a reference partition table, what it is your ability to partition two tables which are bound together in a parent-child or reference integrity relationship. The reason that can be useful is sometimes the thing you want to partition on is only in the parent table. And what we had to do historically was we have to drag that parent key down into the child table as well. So for example, if I had an order items table, you can see here I'm partitioning by order date. Now, if I'm doing a parent-child relationship, order items here, the only thing I need really from the parent table is order ID. But historically, if I wanted to partition the order items table, which by definition is probably larger than the orders table, I would have to copy the order date down as well in order to do that, which is a bit of a pain. Reference partition, which came way back in Oracle 11, says I can reference the foreign key. The foreign key definition here says that order ID references the parent, so I can partition on the foreign key, so to speak, which says as an order ID comes into the order items table, go and look at the orders table using the foreign key, find the order date, and partition the data appropriately. So both these tables now will be equi-partitioned on the order date. That's how reference partitioning works. But as you can imagine, once you do that, there's some rules that we've put in place to keep these two tables in sync. So let's put some data in there. It was partitioned on 2 years, 2018, 2019. So I've got some data for 2018, some data for 2019, and for each case, I've got a parent row and a couple of child rows as well. So I've got the normal stuff you can see here. I'm going to do it with 6 rows, but we can scale this out to 20 terabytes. It's not going to make any difference. So this is the problem that comes along. The orders data type here was originally number 5 for my order ID. I've been very, very successful. The number of orders is growing, and I try now insert a very large order number. It says, yep, that's a problem. What I want to do is make the number larger. But it says here, this is the error that this person is getting. If the partitioning column is the one you're trying to change, then you are not allowed to change the data type. Even just to extend it, you're not allowed to do that. That'd be a cool enhancement request, but you're not allowed to do it on the child table. You would be allowed to do it on the parent table. The parent table can be altered to make that number data type larger. But now you've got a problem, because now you've got number 10 on the orders table and number 5 on the order items table, and you can't change it, and you're stuck. So we want to try get number 10 into both these tables without having to shuffle all the data around. The way we're going to do it is with a series of exchange partitions. So the first thing I'm going to do is for each partition that I've got in my orders table, I'm going to create a standalone table. So in this case, I've got orders 2018 and orders items 2018. This is, once again, a foreign key that goes back to the orders table. So this table here, these two tables here are going to represent the existing partitions for the year 2018. I then do the same thing for 2019, have an orders table and an order items table, once again with a foreign key. So once again, these two tables will represent the 2019 partitions in my order and order items table. Having done that, I can now exchange the data out. I can simply say, yep, take 2018, exchange it out, 2019, exchange out for my orders table. Now the question is, what about my order items table? Well, I don't have to do that. One of the nice things that you can do is what we do, a cascading exchange. Because the two partitions are linked by a foreign key, and the two standalone tables we created are linked by the same foreign key, when we do alter exchange partition cascade, it doesn't just exchange the orders partition, it exchanges the order items partitions as well. So effectively, this has already been done for us. And as a result, now there's no rows left in my orders table and no rows left in my order items table. All the data in there has been swapped out just with dictionary exchanges into my standalone tables. Now that they are standalone tables, I can do a standard modify. So modify orders 19, modify orders 18, modify order items 18, etc. And for completeness here, I even increased the order item ID, but that was not a problem anyway. That wasn't the partitioning key. The key thing is these first 4 here. I've now made the data type larger. Now you might think I'll just exchange the data back in now, but that doesn't work because my standalone tables have a number 10 data type and my orders table is number 5, and the database quite correctly says, you've got a mismatch here, you can't do this. So I can't just flick it back in. But what I can do is create a brand new orders table, which is partitioned with now this new data type number 10, a new order items table, which also has order item ID and order ID number 10. It's partitioned by reference. This table is totally empty, but it has the right data types. So now I can exchange my standalone tables into my new orders partition table for 2018. Once again, I'm using Cascade. That'll bring in the order items table as well. Same with 2019. And at the end of it, my new orders table has the order data and my new order items table has the order data. Now, I've still got an issue here because these are not the right names, but that's just a case now of just renaming. Rename my orders table to old orders, I can drop these, etc., and then rename the new one to order items, and the job is done. If I describe them, there we go. I have number 10 and number 10, and I never moved the data around. I just had a lot of exchanges. All of this obviously has to occur. Let me try again. All of this has to occur during an outage because we are shifting things around. But at the end of the day, we actually have everything we need in our orders table and our orders items table, and it was just dictionary operations that occurred. So that's not too bad. So hopefully that helps that one. Reference partitions is one of those contentious ones in the sense that there's a reasonably large list of restrictions in reference partitions. And they're all good restrictions in the sense that we want to make sure that you never get any kind of corruption. You don't want to get orphans and dodgy parent and child records, etc. So we're very strict in how we lock those two tables together. So that's both a good thing, but obviously introduces some restrictions. It's not uncommon. I've seen people that restrictions are too significant for the flexibility they would like to actually say, I'm just going to go ahead and copy the partition key down. So don't feel that just because we introduce reference partitioning, you should not be, for example, taking use of the old style historical method of copying the partition key down. Sometimes that works just as well. A good example of that is sometimes you want to have a local primary key indexes in both the parent and the child. Sometimes the only way to achieve that is to copy the partitioning key across both tables and do some application constructs to be aware of that. So I just want to stress reference partitioning is cool, but just because it's there doesn't mean you have to do it whenever you've got partitioned parent and child tables. Okay. I must say, maybe it's because I've been away for 2 months and you're all upset with me, but it's a quiet chat line tonight, but not to worry. Next one, lob compression. Here's the question that came in. We're trying to use the new 23AI alter table lob shrink space, but I don't think we're getting any compression. Is this a bug or are we doing something wrong? So the first thing I need to stress is this is not a 23AI feature. You don't see it in 19C, but that doesn't mean it's a 23AI feature. It actually came along in 21C and just happens that most people are seeing it now in 23AI. It's pretty cool. And one of the things that's interesting is I had a bit of back and forth with this customer, and I said, how come you think it's a 23AI feature? It's been there in 21C for a while. And they go, oh yes, we've tried it in 21C and it works fine, but doesn't work in 23AI. That's why they said they think it was a bug. So let's have a look-see here. Quick question there. You said, isn't it good practice to define a primary key as a number to begin with? No, I would say not, Judith. In fact, funnily enough, you say that. I assume you mean number without any precision on it. Funny enough, I published a video just the other day about the difference between number and number, integer and float, and decimal and float, and all the different things. So I would encourage you to have, I'm sure you've already seen it because you're so active, but if not, go have a check of that. And I think I justify my claims as to why sometimes number is not perhaps what you want to do. Okay, where were we? Oh yeah, back into our lob. So let's see why there was a bit of confusion here between this alter lob shrink space command in 21C versus 23AI. So I'm going to do it in 21C first. I'm going to create a table called C. We're going to store it as a secure file because that's now the preferred and it's definitely a much more superior mechanism for using lobs. I've chosen disable storage in row, not for any reason other than the fact I want to make sure that my lob segment gets nice and large so we can shrink it. This particular feature doesn't really matter whether it's enable or disable storage in row. I'm going to install 1,000 lobs, each of 32K, so that gives me 320 megabytes of characters, but in a UTF-8 dataset, we store 2 bytes for every character, so I'm thinking that should come out, at about, is that 700 megabytes? 76 megabytes? Yeah, 76, I got my mathematics slightly wrong, but so 32 megabytes times 2, not 320 megabytes, 32 megabytes times 2 in terms of UCS2 format gives me about 70 or so megabytes. That's all the data in my lob. Now I'm going to take all those lobs, which are 32K, and shrink them down to 100 characters. So I've dramatically reduced the size of the lob. And we go look at the lob segment, and it got bigger. The reason it got bigger is not a bug. What happens is just like normal database rows, we need to be able to do read consistency for lobs. And unlike using the undo area for that, what we do is the lob itself stores old versions of the data, such that if you have queries that are already running while that update was running, they would be able to see the old versions of the lob. So lobs themselves manage their own sort of old versions of data to provide read consistency. But I might be looking at this going, I know all my lobs are very small. I don't have many rows. I want to get that space back. And so I can do this in 21C, and I should have set this running because it takes a little while. You can do alter table modify lob and then nominate the lob and shrink space. I want to stress some versions of the documentation and some posts out there didn't have these brackets in there. If you just do shrink space without the brackets, you get an error. It took me a while to poke around and find the right command here, but just be aware that some blog posts out there and the docs, some older versions of the docs, I think the initial 21C versions didn't have that correct. But having done this, it worked very well, and I've gone from 80 bytes down to, what have we got, 18 megabytes. So yeah, I've had a good gain of space there. So I'm happy. So that works fine in 21C, and back to our initial question, it says, is there a change or a bug in 23AI? So let's have a look. Let's do the same thing in 23AI. Now I'm connected to 23AI, and once again, just on a VM on this machine. Same table, same amount of data goes in. I look at it, it's the same size. I do the same update. It's now about 85 megabytes in size as well. So as we can see, it looks like the same. I do shrink space. Whoa, look at that, instantaneous. See how much faster it is. That's pretty cool, hey? Except it didn't really do a great deal. The first example in 21C went from 84 megabytes down to, 16, 17 megabytes? This one from 84 to 75. I didn't really gain anything, did I? And the question is, which is broken? It looks, first of all, like 23AI is broken, but maybe it's 21C that's broken. And let me justify why I think 21C is actually problematic here. If I look at the undo retention parameter on this database, it's 900, and that's the default on most databases, 15 minutes worth of undo. If we think back to our 21C version, in theory, I should have held on to 15 minutes, 900 seconds worth of old lob segments, even if someone did shrink space, because there could have been queries running. Now, I should have, by all rights, held on to that data. I shouldn't have been able to shrink it until that data was more than 15 minutes old. So that's actually what's happening in 23AI. We've actually fixed that process. We say, whatever you're doing to the lob data, we should preserve your under retention. And just to demonstrate that, I'll now set my retention to 30 seconds. So it only needs 30 seconds of old data to be kept in there. Now I can run, this is, you've probably seen this, it's in the docs about how to dig into what space is used in any segment, including lobs. So I'm using DBMS space here, right? So if I do this, because I waited 30 seconds, I waved my hands and talked a bit long and showed this command here. I deliberately want to take 30 seconds. It now says in this lob segment that I had, most of the data is now expired. As a result, the retention for that data, that lob data, is now gone. So now when I run, it's 75 now. Now when I run shrink space, yep, I now get the space back because all that data has finally become expired. So it's the same process, but it's actually, I would claim, more correct in 23AI because we're not going to go blow away stuff even if you've done a shrink space until you've actually satisfied the undo retention. Okay, so we got some question here from Hemant. Raise the question how undo retention is tracked in lobs. Be interested in digging into the details. That is what we could do an entire question on that, but very, very briefly. If you go back, you're a dinosaur like me, back in the old days when we introduced lobs back in Oracle 8, and this was the case through to Oracle 8, 9, I think up to 11 maybe. When you created a lob, you would actually nominate a thing called %version, which is how much of the lob space am I prepared to accept for old copies of the lob. And you might say 40%, which means as a lob aged and got changed and updated, you would allow up to 40% of the segment size to hold old versions of the lob. Once old versions exceeded 40%, we'd start ditching the older stuff. Now the problem with that, of course, is when we introduced automatic undo retention in Oracle 9, we said one setting to rule them all. Isn't this fantastic? You just set that and that's your under retention. And then we went, except for this very strange percent version business in lobs. And so that was a bit weird. What we did was we said, okay, you've noticed now that when you create lobs nowadays, there's a new command called whether you want to use percent version, because we support the old version, or you can just use the keyword retention, which says the lob obeys the same under retention parameter that we have in the database. And internally, the structure is the same. We're using the lob itself to store old versions of the data, but in terms of when we age it out and get rid of it, it's not about the segment space anymore. It's about meeting the requirements of the under retention parameter. So it gives a consistency database wide. Hopefully that helps. And as you've seen in the demo, DBMS space users can show you how that data is floating around. So hopefully all that makes sense. I'll reset my under retention back to 900 just so I don't screw up the rest of my database. One cool thing that I didn't do in the demo, and I put a blog post reference here, is another thing that's introduced in 23AI is automatic shrink. Just like we have automatic tasks with things like optimizer, stats, segment advisor, etc. One of the new automatic tasks in 23AI that you can turn on, it's off by default, is it can go looking for secure files with lots of expired blocks and just do that shrinking for you. So you don't have to go hunting around and actually run those commands manually. This is a task that will just in the background go look for old outdated data in your lobs and drag that space back. And that's a nice utility because some people are very space constrained. For example, if I was running database free version, I would probably turn this on because I don't want my lobs growing to a large size just so I can have old data floating around for versions. I want to be very aggressive for getting that space back because we've only got 12 gigabytes to play with in the free version of the database. Or similarly, if you're using free autonomous where you've got 20 gigabytes, maybe turning that thing on would actually be a very cool thing to do. But yeah, 23AI has a new automatic shrink task as well. Optimizing VPD queries. No, that's not a disease. That's virtual private database. Here's the question that came in. We have a query that runs slowly. However, it's using virtual private database, so we cannot see what the generated query is. How do we go about tuning the query? And there's a couple of techniques here we'll show you in a demo. But the cool thing is, even if you want to tune a query that has virtual private database predicates applied to it, you'll see in a second that you actually don't need to see the entire SQL. It's useful to know what it is, but you actually don't need to know the entire SQL in order to tune it. And let's have a look at our... If you've never seen virtual private database, the way it works is you effectively apply what we call a policy to a table or a view, and that policy defines what additional predicates will be added to every query that comes against that table. It's a way of limiting the number of rows that people see. And the way we do it is what we call with a policy function. So in this case, I've created a very simple policy function. It's called scott.emp policy. A policy function always takes in the username and the table name, but I'm not going to use them. And what I'm doing is returning a where clause predicate. So this one's very, very basic. I'm simply saying whenever anyone queries a table with this policy on it, I'm going to use it on the employee table. We're going to apply department number equals 10. So you'll only ever be able to see department 10 whenever you query the employee table. Obviously, in real life, these things are designed to be flexible based on who's logged in, what application's using it, etc. You use bind variables, etc. to work out, okay, maybe if I'm querying the employee table, I can only see employees that I'm the manager of. So normally it's far more sophisticated than this, but I'm keeping the example very, very simple. So I'm going to let anyone run this policy. Normally I'd be a bit more prudent here, but I'm keeping the demo such that anyone can do it. Then I add a policy. I'm calling that particular policy, I'm calling that function name. Whenever someone queries the employee table, I'm creating a policy called VPD policy, which says run this policy function, find the predicate, department number equals 10, find that string, and add it into the query. So now if I connect to a user called demo, which actually has queries on query access on the scott.emp table, I do select star from scott.emp. Anyone that knows scott.emp knows it's normally got 14 rows for 3 departments, 10, 20, and 30, but I only see department 10. Invisibly, that predicate has been added by that policy function. It's a great way of implementing security. If I want to see the SQL ID for that particular SQL, I can see select star from scott.emp is SQL ID, GG, QNX, or whatever. I put it out here just so I can use it later on. If you've never seen this, this is a SQL Plus, I think, 19 and above, maybe 21 and above. You can actually get the SQL ID for any SQL statement that's run from SQL Plus. So I'm going to connect now as a DBA. I'm digging into seeing why this SQL is running so slowly. If I go look in VLSQL, notice that even a DBA doesn't get to see what the actual generated predicate was. They simply see the original SQL statement. What they can do though is query $VPD policy, once again for the known SQL ID, and it says, oh yes, for this particular SQL, we added the following predicate. This is useful and a very useful view to have, but it still hasn't shown me the actual SQL. It simply said, yep, you had select star from emp, and we had department number equals 10. We can make the logical leap that it did where department number equals 10, but it doesn't actually show us the actual SQL. Interestingly enough, even as the user just ran this query, there is a way of seeing the SQL. And the reason that's useful is normally a user, just a typical user that's not DBA, well, they can't see $SQL, they can't see $VPD policy, so they can't see these things. And maybe this is a security concern, maybe it's not. What it does do is we have a utility called dbms utility expand SQL text, which says when someone runs this query, what transformations occur to eventually get this over to the optimizer. And if I run it, it pops out this. It says, this is the query that we probably would have optimized. And it says, yep, we're going to blah, blah, blah. It's an inline view. I won't print it up, but you can see there's our predicate. So this is the actual SQL that's going to run. It's effectively select star, expand it out to the columns, where scott.emp, where department number equals 10. So we can actually see that query, which is pretty cool. So I'm just seeing, sorry, I thought my dog needed to go out. Interestingly, this is why you've got to be careful what you put in your predicate functions, because the demo user here only has create session and create table. He doesn't have any special execute facilities on this. So dbms utility is publicly granted. So be aware that what you put in your actual predicate will actually be exposed at the moment. The final question is, of course, is how do you tune it though? It's all great to see, oh, this is the query I can see. How would I go about tuning it? Because this is not an SQL I have access to. It's created on the fly by the database. Here's how we can do it. The first thing I'll do is, let's assume this is the bad plan. Someone said this select star from scott.emp is currently running slowly. Obviously, it's not running slowly here. It's a 3-row result. But I can see that in this particular case, with nothing else involved, the database is doing an index range scan on this index. This index is on the department number table, and it's using it for that. So let's assume this is our slow query, and I've decided, well, what I really want to do is do a full table scan because it's 14 rows, fast just to skip the index altogether. Let's just do a simple full table scan. How do I force that in there, given that this query doesn't have where department number equals 10 in it anyway? I can't see it. How do I force that in there? Well, you can use any trickery you want. I could actually put a hint in there and generate a brand new SQL ID, but I'm going to just do this nice and quickly for cheating purposes. I'm going to make the index cost incredibly expensive, which means that index will no longer look attractive. And now when I do select star from emp, I can see I get table access full. And this is the plan I wanted. I could have done it just by forcing a full hint in there, but that would give me a different SQL ID. By simply changing my optimizer environment, now the existing SQL is giving me the plan I want. Whatever way I choose to do it, I've now got effectively the two plans I want. I've got one that uses an index, which is in my view is slow, that's the default plan, and this new plan which I would like to force in there. Whenever I have an SQL with a plan that's good and a plan that's bad, and I want to control which one it is, well, that just screams out SQL plan management. So we can do that. I'll set my optimizer cost back to 100. If I go look at VLSQL plan, we can see for this particular SQL ID, there's now two plans. There's this one, which ends at 885, and this is the default plan, which is using the index that was there. And then there's another plan, because I changed my optimizer environment, which is now ends with 932, which is the table access full. I've got two plans in my cursor cache. So what do? Well, SQL plan management lets me control this really easily. For this particular SQL ID, go get the two plans from the SQL circuit place, let's try that in English. Go get the two plans from the cursor cache, but both of them I'm saying are bad plans. I don't want you to use them. And then I simply say, go get the plan, the second plan, load that in, and actually change the enabled from no to yes. So now I've got two plans loaded into the cache. The initial plan, which was the index, is no longer allowed. And the new plan here with the full table scan is allowed, which means now when I do select star from scott.emp, which behind the scenes becomes select star from scott.emp where department number equals 10, it's doing table access full. And even though we got the filter in there. So just because we don't see the final SQL, even though we could poke around and see it with DBMS utility, we don't actually need it. As long as we know the plan we want to achieve, then we can use SQL plan management, even though it's got a virtual private database predicate, to actually force in the plans we would like to see. So it works out pretty well. That does bring up a footnote, though, and this is something I'm going to raise with the security team as to whether they think this is worthy of concern. Be careful what your policy function generates in terms of predicates, because DBMS utility is going to reveal them. If you had, for example, a predicate which was where credit card details equal something, or where password equals something, or something like that, none of the stuff you should have in your database anyway. But if you had some sort of sensitive data that's being generated as part of a predicate, be aware that Joe Schmo user, without any serious privileges, is potentially going to be able to see the value of that predicate because your DBMS utility expands SQL text. This is another good reason why whenever you're putting data into predicates in your policy functions, typically they should always be bind variables, which normally means your predicates should be taking advantage of using application context and the syscontext function. You don't want to be putting literals into your policy functions because A, they might not be as well shared, but B, if they're sensitive literals, they are exposed to the world using DBMS utility expand SQL text, and you'd need to be very, very careful with that because it introduces a security loophole. What have we got left? 9:53. Can we squeeze one more in? I reckon we probably can. This one isn't too long. We might go 1 minute over, he says bravely. SaaS or software as a service, schemas and contention. Here's the question that came in. We run SaaS for customers where every customer runs the same application, but we give them their own schema to run in. At busy times, we are seeing a lot of cursor pin contention in the shared area. Is this due to our schema per customer design? Maybe switching to pluggables is an option. It is the fact of your design that is causing this problem, and I use the term here when the same SQL isn't. And that is, if I run select star from my table, but I run that in lots of different schemas, because each copy of that table is slightly different. One might have 10 rows in one schema, might have 100 rows in the other schema. It's the same SQL, but it can't be treated identically by the database. And that can introduce some contention issues. And let's have a look at our last demo. So I'm going to flush my shared pull out, and now I'm going to create a series of, I think I've pre-created a series of users, all which have the same table. So I log into the Scott table schema first, Scott table. I log into the Scott schema first in PDB21A, and I do select star from department. And we can see the SQL ID for that is 3154 something. I log onto a schema called demo in the same database, and I do select star from department. I log into a schema called demo2 and do select star from department. I log onto demo3 schema and do select star from department. If I connect as a DBA now and go look in my library cache, what do I see? I see for that same SQL ID, 3154, etc., I actually have now 4 different versions of it. And the reason I have to have 4 versions is even though the table is called department, it's 4 physically different tables. One might have 10 rows, one might have 1,000, one might have 1,000,000, one might be a view, one might be a synonym. The SQL text is the same, but the underlying environment and objects are different, which means each of these needs to be a different cursor because they need different plans, they different access rights, etc. All these things are different SQLs, even though they're the same SQL text. Where that becomes problematic is if select star from department is a query that's run very, very frequently, very aggressively, then when they're being parsed, even soft parse, they all come into the same spot in the library cache. Yep, I'm 3154, etc., etc. And he goes, oh no, you're not the right version. You need to be this one. So we have contention for these common areas in the library cache because they all map to the same SQL ID, but they don't map exactly to the same actual objects in the database. So we start seeing contention. While someone is pinning cursor 0, someone else is trying to load in cursor number 4 and cursor number 5, etc. Now, maybe a pluggable helps. Maybe rather than doing it all in the same database with different schemas, what if we had different pluggables? So here I've got another schema called demo B and pluggable PDB21B. He does select star from department as well. But when I come back in, let's go now to my root container, which can see all the pluggables. You can see that the actual library cache is not separate by pluggable database. It is global. We have a single library cache for the entire database. So now I've got my original 4 cursors for that same SQL text. And now for a different container, this is PDB21B, I have another version of the same cursor. So the library cache is global. So this problem in multiple pluggables isn't really going to help. We still have that contention for this same area in the shared pool. So what are the solutions? This talks about what the problem is. How do I actually solve it? The only really way you can solve it, well, sorry, let me backtrack. There's 2 ways you can solve it. Number 1 is you can contact Oracle support. There are some hidden underscore special parameters which are designed to separate things in the library cache that would not normally be separated. We try to sort of spread out the contention. I'm not a fan of that because the moment you get into underscore special underscore parameter territory, suddenly you're now this lone wolf out in the database world. If you have a problem that requires support assistance, who are you going to call on? How is support going to compare you with 25,000 other customers? Because you're the only person with this particular scenario. The moment you get into that your database setup being very, very niche, you're likely to run into bugs that no one else has ever seen, including support. That's not a good place to be. So you can do that if you want. If you cannot touch the code in any way, shape, or form, then maybe that's one path you are forced to go down to. But ideally, I would look at other solutions. And the solution really is you need different SQL. So number 1 is, first of all, is you only see this problem if you're running the same SQLs incredibly rapidly. Library cache contention only happens when you're really pounding away at the library cache. So the first thing I'll do is check, do you have an underlying application issue? If I'm running select star from department 1,000 times a day, I'm not going to see any contention, no matter how many schemas I have. If I'm running it 1,000 billion times a day, then yeah, I'm going to see contention. Maybe that's the problem. Maybe it's the volume. Check to see if this SQL is being run, for example, recursively, in a PL SQL call, etc. So check your application first, if possible. If you can get the execution count down, that'll take care of the contention by itself. If not, you need to separate the cursors. One way of doing that is very simple. Put some text into the cursor that makes it unique. I connect as demo and do select cust1, for example, and then connect demo 2 connects as customer 2, puts that piece of text in the text. You can see the SQL IDs are different, and therefore I've removed the contention. Demo 3, I think, put here, would select, put this piece in the text. So now you do need to change your application here because it now needs to construct the text appropriately to actually include some special characters in there to separate the text. Now, hopefully, if you're looking at this, you're going, well, hold on a second. If I've got 1,000 different customers, that gives me 1,000 different SQL statements. Yes, I don't have contention for a particular same SQL ID now, but aren't I heading toward the kind of issues that we use bind variables for anyway? The whole reason we invented bind variables was not to get SQL cursor cache pollution like this with thousands of different versions of the same SQL, and that is valid. If you have massive volumes of customers, let's say 10,000 customers, then what you start doing is taking more intelligent solutions. For example, the ORA hash function, I can pass in, say, the word cust10 and say, give me one of 10 hash values. It would give me hash value of 8. So for customer 1, I would use hash 8. A whole stack of different customers, when they get their hash function applied to them, are going to resolve to one of 10 hash values. That's going to leave me with only 10 different versions of this SQL, hash 1 to hash 9 or hash 0 to hash 9, in my cursor cache. And I can simply adjust this value of 10 here to decide how many versions of the SQL I'm prepared to have in terms of balancing between number of different SQLs versus alleviating contention. For example, if I had 1,000 different customers, you can see here that I would evenly spread those 1,000 customers, 100 each customers across each version of the SQL. I have that choice. So they're the solutions you can look at doing. Now that gets me to 10. Oh, look at 1 minute over, as we said. So let's wrap it up. Thank you very much for your time. Once again, I apologize for not being here for office hours the last couple of months due to travel commitments. My next travel commitments are all early in the month. That's early September for Poland, Vienna, and Bucharest. Early October for AI World, and early November, I think, for another conference coming up later in the year in South Africa. So hopefully, because my office hours are normally toward the end of the month, I should be online for October, November, and September, even if I can't get them in the right order. But as always, thank you very much for your time. We don't need to share that anymore. Thank you for contributing to the poll. I'll pass those results on. And yeah, hopefully you enjoyed all the content tonight. And we'll see you hopefully at AI World or hopefully at a conference in Europe. Please come say hi. Otherwise, we'll see you next month on Office Hours, everyone. Bye for now.